Okay, ladies and gents, let's chat. Let's chat it up. So in number one, it says, here we go. A ball is thrown straight down from a 120-foot tall building with an initial velocity of -8 feet per second because it's going down. Its height above the ground t seconds after its drop will be s of t. So that's the height. And it doesn't give you v sub 0 or s of 0. You have to plug that in. So it wants you to first write the position function. So we have to plug in, what's my initial velocity? V sub 0 is -8. And then S sub 0 is your initial position. So where am I starting? 120 feet, right? Okay, so my position function looks like this. -16t squared minus 8t plus 120. That's S of t. Does that make sense? Okay. Now, question. If I were to just, like, this means I threw the ball down, right? At an initial velocity. What if I just dropped it? What would be my initial velocity if I just dropped it? 0. You see the difference? If I just drop a ball, the initial velocity is 0. So then you don't have to worry about that middle term, which is a couple problems on your worksheet today. Okay. How long does it take the ball to hit the ground? What do I do? Set what equal to 0 specifically? S of t. So make sure you label everything. We're going to set the height is 0 when it hits the ground, right? So I set the height, S of t equal to 0. So, and solve. So -16t squared minus 8t plus 120 equals 0. Always take out that GCF first, -8, right? 2t squared plus t minus, is that 15?
Yes.
Okay. And then we do, like, you can divide by -8 and that cancels it out, right? So really it's just this, and you use X method. Multiplies to the first times the last, adds to 1. So, yep. Positive because I took out a -8. That makes sense? Did you take out a negative originally?
I just took it.
Okay, then that's fine. You'll have opposite. You get the same thing.
Oh.
Yep. Yeah. So I want 6 and 5, and I want 5 to be negative. Divide by the leading coefficient and t. This reduces to 3 over t. Factors are t plus 3 and 2t minus 5. You set them equal to 0. T is -3 and t is 5/2, or 2.5. What are my units for t? Sorry. Units for t are seconds. So does it make sense to have -3 seconds? No. So for this problem, it's going to hit the ground at 2.5 seconds. Make sure you clearly cross off that that's not an answer choice. Okay, good. Now I want you to find the velocity with which it will strike the ground. That's called the impact velocity. So if I say, hey, find the impact velocity, that's what I want. What do you do? First of all, how do you get velocity?
Sure.
Derivative, right? If I say, give me the velocity, then you derive. What if I said, find the average velocity? You wouldn't derive. You would use the slope formula.
Yeah,
so just velocity, plain old velocity, we derive, right? S prime of t is the same thing as v of t, velocity. So it's a really easy derivation. It's -32t minus 8. Yeah? Then to find the velocity which is striking the ground, what do I plug in for t? 2.5. And pop it in the calculator. -32 times 2.5 minus 8. Pop in the calculator, you get -88. And what are my units? You have to write units. Feet per second. Y over x. The units for derivative is y over x, feet per second. It's a rate. Okay? Does that help? Do you have any remaining questions? Like, are there any phrases that you're confused about specifically that I need to?
By the y over x. Like I get like the feet per second. I don't understand.
Okay, so I keep saying the units for derivative are the units of y over the units of x. So like, and whatever is represented by that. In this case, what represents y? S of t. What are the units for S of t? Feet. So that would be like feet. And then what are my units of x? What is x in this case? T. So like my units for t are seconds. So no matter what I give you, if I say, I could make something up. If I say like, well, I don't know, f of x is 2x, puppies. Okay, whatever, puppies. And then maybe the function represents the money made from selling puppies at a pet store. What would be the units of my derivative? What's the units for y? What represents y? F of x. What are the units of that? Money. So it's the dollars per, my units for x are puppies, right? So if I say x represents the number of puppies and the outcome of that function is dollars, right? That's dollars per puppy. Okay. All right. Silly example, but okay. Hey, so today you are, the practice assignment is 2.2 worksheet 6.